Alright, so today we're going to start a new unit. It's called two-dimensional kinematics. So in this video, we're going to look at vectors and vector operations. So we'll be adding up vectors. And I want to start off by looking at the sign conventions. So when we have north, north is considered positive. East is also considered positive, whereas south is going to be negative and west is going to be negative. So that will be in the calculations that we see later on. And then we have some examples of some vectors. So here we have a vector with a magnitude of A and a direction of east 35 north. So we go east and then 35 degrees to the north. And similarly with vector down here, a magnitude of B, so that's the length of the vector, and then the direction of east, 65 south. So from the east line, 65 degrees towards the south. And then just an example vector here, we have 14 meters of west, direction west, 25 north. So from the west, 25 degrees towards the north, and then a magnitude of 14 meters. Alright, so now let's look at some examples. So here we have 18 meters west plus 15 meters north. So step one is going to be split the vector up into components. So step one, find components. So our first vector, we're going to be looking at 18 meters west. The first value on the coordinates will be our direction in the east-west, or the magnitude in the east-west direction. And then our second value in these coordinates will be the direction in the north-south, in the north-south line. So our first vector here, or actually I'm gonna put the room for both vectors and we're gonna be adding them up. So here's our first vector, 18 meters west. So since we're going in the west, remember our wheel west is negative, so we're going to put a negative in front of our 18. And then in this vector, what distance do we travel in the north-south direction? Well, it's 0. All right, and then our second vector, 15 meters north. Well, in the direction of east-west, it's going to be 0. And north, we're going to have 15 and positive because it's north. So when we add these two up, we get a resultant vector. So this is our resultant vector. And because this is negative, this is the direction west. And because this is positive, the direction is north. So what we have now is a vector 15 north and 18 west. So our resultant vector, when we add them up, is going to be this, with some angle theta. Now let's find the magnitude. So that's the length of the vector and this angle. So step two, magnitude. All right, what's the formula for the magnitude? Well, if we look at the Pythagorean theorem, this vector, we can actually move over to here, and we have a 90-degree triangle. So we're going to use SOHCAHTOA, and let me try and fix this here. you know what, I'll forget about this, I'll draw it again. So we're going to have a new triangle. Got a triangle here, keep a little distance here now. Yes, so we got a triangle here, and we want to know the side length x, that's the magnitude. So according to the Pythagorean theorem, or SOHCAHTOA, usually the easiest way to do it is with the Pythagorean theorem because we have two side lengths. So if you remember the Pythagorean theorem, we're going to go 18 squared plus 15 squared is equal to x squared. So let me write that like this. So x squared is equal to 18 squared plus 15 squared. So that's our side lengths of the triangle. So that means x is equal to the square root of 18 squared plus 15 squared. And when we type that into our calculator, I encourage you to do this with me, but we get a value of 23 meters. So that is our magnitude. Then step 3 is to find the angle. Step 3 is the angle. So before I start writing here, how to find the angle theta? Well, if we look at our SOHCAHTOA, and I want to use these two sides here. Well, if we're looking at a reference angle, the two sides that we know the values of are going to be the adjacent and the opposite. So we're going to be using tan. So that means the tan of theta is equal to opposite, that's this one, over adjacent. So the tan theta is equal to opposite, 15, over adjacent, 18. So let's rewrite that over here. We're going to write the tan theta is equal to 15 over 18. And then when we want to isolate for theta, we're going to take the tan inverse of 15 over 18. And then type this into your calculator, remembering to ensure that your calculator is in degrees and not radians. We should get an angle of 39.8 degrees. So for our final answer, the resultant vector, well, we have a magnitude, 23 meters, and we have a direction. So let's write the magnitude first. We have 23 meters. And what's the direction? Well, it's 39.8 degrees. But in what direction? Well, going back to our components here, we have a west and a north. And we're always going to write our east or west first and our north or south second. So it's going to be west, 39.8, I'm going to round that to 40. And then our final direction in the up and down is north. So west, 40 degrees north. And I want you to look at this and compare it with the little sketch that we made. So that's our final answer here. And compare this to the little sketch we made here. So we have 23 meters. We're looking at this blue vector here. It's 23 meters. And just checking to make sure these numbers look about right. Well, if we have 18 and 15, the hypotenuse of 23 passes the sanity check. And for this angle, well, we're going to go west and then north. So west, and then how far is this angle towards the north? Well, we found it's 40 degrees. And does that match our diagram? Well, yes, it looks like it's going to be less than 45 degrees, but just a little bit. So 23 west, 40 north is the correct answer. Let's move on now to part B. And I will start doing these a little bit faster now, just because we're starting to get the idea of it. So there's going to be one more important step that we have to do with this question, and that is, notice that we are given the coordinates, or the vector, north 33 west. And what's important to us is that we have the direction from east-west first, and the north-south direction we need second. So we're going to rewrite this vector. It's going to be an equivalent vector, but with the signs switched. So west and north. And that changes our angle. And what I'm going to do is I'm going to sketch this. So we have 120 degrees. It's north 33 west. So it's going to look something like this, 120, right? And this is 33 degrees. Now, what vector can I write that's equivalent to this? Well, what if I do west 57 north? Let's sketch that and see what that does. Well, if we start west and then go 57 degrees north, well, this is going to be our vector. Now, can you see how these two are the same vector? Because what we're doing is we're taking 90 minus 33 is equal to 57 degrees. So that tells us that in both of these cases, this angle here is actually 57. And this angle up here, well, it's 33. So these are equivalent vectors, just like these are equivalent vectors. They're just written in a different way, and we need them to be written with the east or west, followed by degrees, followed by north or south. And then the second vector here, well, it's just going to stay 100 kilometers north. All right, let's add these vectors. So when we have an angle here, what the components are going to look like in the east-west direction is going to be the magnitude times cos theta. And here we have the magnitude, magnitude times cos theta, and here we have the magnitude times sine theta times sine theta. So with this first vector, how can we write this? Well, magnitude is 120 times cos theta, so times cos 57. Remember, make sure that your calculator is in degree mode. And again, that's 120 magnitude multiplied by cos theta, so cos 57. And let's do the same thing with the north-south component of the first vector. So in the north-south, it's the magnitude times the sine of the angle. So 120 times the sine of 57 in degrees, that's going to be 100.64. And then moving on to our second vector, the one that we're going to be adding. Well, in the east-west direction, there's 0. And in the north-south direction, well, it's going to be 100. And I want you to also take note of, because this is west, we're going to put a negative in front of the 65.36, because west is going to be negative. So let's add these up. The sum, the resultant vector, is going to be 36.36, comma 264. That is our resultant vector. And because this is a negative, we go to west. And because this is positive, it's going to be north. And remember, your first component of the vector always tells you whether you are in the east or west direction and how far. And the second tells you how far you are in the north or south direction. So let's sketch out this vector now. So the north component is 264, or 200.64 rather. And our west component is 65.36. So our resultant is going to be something like this. The magnitude of x that we don't know, and an angle theta. So that was step 1. Let's move on to step 2. And that is to get the magnitude. So x, which is our magnitude, is going to be equal to, similar to the last example, the square root. Remember, this is the Pythagorean theorem. If we bring this, we have a right angle triangle, and we know 2 of the side lengths, and we're looking for the hypotenuse. So this is the Pythagorean theorem, and it should look familiar to you. All right, and typing this into our calculator, we get an answer of 211 kilometers. Remember to keep our units straight. I almost wrote meters, but it's important to keep the units consistent. So that is our magnitude. And step 3 is to find the angle. So the angle, if we remember from the last example, is the inverse tan of the opposite over the adjacent. So here's our theta, our opposite, and our adjacent. So theta is equal to the tan inverse of the opposite over the adjacent. If we plug this into our calculator, we get 72 degrees. So that means our resultant vector remember, we got now our magnitude, and we have our direction. So 211 kilometers, and our direction is west and north. so west. Then remember our angle, 72. So west, 72 degrees north. All right, let's do example C now. We have 250 kilometers per hour, south 75 east, minus 250 kilometers per hour in a direction of north, 54 degrees west. So we're going to have to edit these vectors a little bit. This one here is equivalent to 250 kilometers per hour. And remember, what we're going to do here is swap the placements because we want our east or west at the front and our south or north at the back. And in doing so, we need to do 90 minus 75 is equal to 15 degrees. So we have east, 15 degrees, south. So it's the same vector. It's following the exact same principle as we saw with this vector here. Right, and then our second vector, the first important step is this needs to be a positive. So how can we add this? Well, it's equivalent to adding the negative of this vector. So if we change our north for south and our west for east, we will have the opposite vector. So south, 54 east. So subtracting this is equivalent to adding this. And then again, we're going to have to flip our directions. We want our east to be the first and our south to be at the end. So bringing it one step down, 250 kilometers per hour, and the direction is east, south. And what's this angle? What's 90 minus 54? 90 minus 54. And is equal to 36. So east, 36 south. All right, so let's add up these two vectors now. We have an equivalent vector to what we're given, and then another equivalent vector to what we're given, but we have reformatted them so that we can work with them in this standard procedure. So again, let's add these vectors. So here we have the magnitude times the cos theta, and here we have the magnitude times sine theta. All right, so let's plug these in. So our first vector, 250, the magnitude, times cosine 15 is going to be 241.48. And that is our east/west direction. And then in our north/south direction, we're going to have the magnitude, 250, multiplied by the sine of 15. That will give us an answer of 64.7. And because it's in the south direction, we're going to have this negative sign. All right, let's do the last vector now. 250 is our magnitude. And then the angle is 36. So for the x direction, 250 multiplied by cos 36 is equal to 202.25. And in the north-south direction, 250, its magnitude multiplied by the sine of 36, that's equal to 146.95. And because this is south, this is going to be a negative. So when we add these up, what do we get? 443.73, comma, negative 211.65. That is south and east. Remember, south because of the negative, and it's east because this is a positive number. All right, let's sketch out this vector. We're going to be going 443.73. That's in the east direction. And then in the south direction, we have 211.65. So our resultant vector is going to look something like this. With magnitude x, an angle coming down from the east axis, some unknown theta. And I just want to go back and label our step 1. So that was our step 1. And that will bring us over here now to step 2. Step 2, where we are going to calculate the magnitude. Step 2 is magnitude. So to calculate the magnitude, once again, same as previous examples. X is the hypotenuse of our triangle. Actually, let me bring this one over. And it shows a triangle with theta inside. So x is equal to the square root. It says again, the Pythagorean theorem tells us that the hypotenuse is equal to the square root of the opposite squared, or of the other two sides of the triangle squared, just like this. So our two side lengths of the triangle squared, and we take the square root of that, that gives us x. So x is equal to, in this case, 491.6 kilometers per hour. And that is, again, the magnitude. So step 3, we're going to find the angle. Find the angle. Same as previous examples, theta is equal to the inverse tan of the opposite over the adjacent. So the opposite over the adjacent. Again, our 211.65 and our 443.73. And with our calculator in degrees, we'll find that theta has a value of 25.5 degrees. So this means that the resultant vector is equal to, remember our magnitude, I'm going to round this to 492. 492 kilometers per hour. And the direction is east and south. So east and south. And then what angle? So we go east and then south to what degree? 25.5. So I will round that here to 26 degrees. That is our final answer.